Now, do you remember a video I did about slope and number lines and that kind of thing? Alright, let's take a look at this number line right up here, and I know you can't see this too well. We have 2 points on this number line. The first one has an x-coordinate of 2 and a y-coordinate of 2. The next one has an x-coordinate of 4 and a y-coordinate of 4. Alright, now if you will remember, slope equals y2 minus y1 over x2 minus x1. Now these numbers are not superscripts, they're subscripts, okay? There's nothing squared about these numbers. This is saying, okay, this is the number that x is in position number 2, and this is the number that x is in position number 1, okay? Here we go, we got slope here. Slope is m, and it equals 4 minus 2, because remember, the y-coordinate up here is 4, the y-coordinate up here is 2, and we always want to use the one that's the highest to the top, okay? Even if you're dealing with negative numbers, we don't want a negative value, all right? That makes some weirdo stuff. Sometimes that happens, but we don't want it here, okay? So we have 4 minus 2 right here, and we have 4 minus 2, okay? And that would be your slope. Alright. Now, what we're trying to do in this particular case, as we have been discussing through derivatives, is we are trying to find, I'm going to draw a circle here, and I'm going to have a line. In this line, here's the circle, here's the line, and this line meets at exactly 1 point on this circle. We're trying to find a tangent line. Now, in order to find the slope of this line, you know, this line could go this direction or this direction or whatever, okay? But right now it's going this direction. The reason why you have to have this slope here is you have to find out is the line sloping this way, or even back towards this way. Well, with 2 sets of coordinates, you can find that pretty easy. But what if you only have 1 set? Then it becomes harder. Alright. That's why we got this derivative equation. Alright. Y equals ax squared. Now, we talked about replacing variables with values. Do you remember in my previous video on this where I had 6 at first and then I replaced it with an x? Okay, same deal here. Here we got x plus delta x. Remember, delta x means change, alright? Now, if the original x was 2, and we wanted to replace it with delta x, what we did is say 2 plus 2 equals 4, okay? So 4 is our highest coordinate, alright? You went up from 2 to 4, and when you did, you went up 2 spaces, okay? Well, actually, you went 2 spaces across and 2 spaces up, alright? And that's what we've got here. Here we got the original coordinate, which is 2, and I'll show you this here. We had the original coordinates of 2 and 2. That was the lowest point on our line. Okay? But we went across 2 on the number line and up 2 on the number line, and that's where we got our 4, 4. Alright, that's what we're going to do here. We're saying that 2 plus 2 will give us the 4 coordinate up, and then 2 plus 2 will give us the coordinate to the right. Alright? So we have y plus delta y equaling a times x plus delta x. This a is a numerical coefficient. Alright? See that a right there? That is a numerical coefficient. Now, using the FOIL method, we're going to expand this out here. Well, x times x is x squared. Well, the outermost terms are going to be x and delta x, and of course the innermost terms are going to be delta x and x. Well, x delta x is the outer terms, x delta x is the inner terms. And then, of course, the last terms are delta x and delta x, which is, of course, delta x squared. I'm going to show this up to you right now. Take a good look. All right, if we add x delta x and x delta x together, we're going to get 2x delta x. Why? Because the numerical coefficient on this x delta x is 1. All right? The numerical coefficient of x delta x here is 1. 1 plus 1 is 2. We're adding the numerical coefficients. We don't care about this part. This is a like term and this is a like term. That's all we care about. If they're like terms, you can add their numerical coefficients together. It's that simple. I told you that in the previous video. Alright, so you have y plus delta y equaling a times x squared plus 2x delta x plus delta x squared. Ta-da! Alright, y plus delta y equaling ax squared plus 2ax delta x plus a delta x squared. Because we are distributing the a across every one of these terms. We've multiplied a times x squared to get this, a times 2x delta x to get this, and a times delta x squared to get that. Alright, as we said in our previous equation, y equals ax squared. These are the original terms. We're going to remove both of them. We're going to remove this term and this term. When we do, we get the delta y. Delta y equaling 2ax delta x plus a delta x squared. Now, if we divide both terms by delta x, we're going to remove one power away from this, and we're going to remove this completely. And that makes delta y minus delta x equaling 2ax plus a delta x. And, of course, if we make delta x here 0 on both sides, delta y equaling 2ax. Exactly what you're supposed to get. Now, I will tell you more in a future video, so stay tuned.